So this problem had a few little pieces of information you had to think a second step on. We have 800 milliliters of water. Remember what we said about water earlier. You can convert it to grams because the density of water is 1 gram per milliliter. So it's the same thing as saying 800.0 grams. So we'll fill that in for our in position. 800.0 grams, not 80. Water specific heat, C, is 4.184 joules per gram degree Celsius. Notice that this wasn't given in the problem. That's very typical. You have to know if you're talking about water that that's the C value for it. And then it says change of T, and notice I'm doing T final minus T initial. So the from is the initial, and the 85 is the final. So T initial is 21, 85 is T final. I'm going to plug those two in. And notice that this one will shorten to the ones position. That gives me 64. And we're going to use our MCAT equation. You notice how it spells out the word MCAT. That's why a lot of people like using the C with it. So we've got 800.0 grams times 4.184 times, don't forget all the units, 64 degrees Celsius. Plug that in the calculator and you get 2.1 times 10 to the 5th joules. Check the sig figs. Our temperature change limited our sig figs, so we've got 2 places there. That's why this is 2.1 times 10 to the 5th. Now on your own, make sure that you are showing that your units do cancel so that you only end up with a joule. So I'm going to go ahead and fill out my Q. I look through and I see that the one dealing with energy is 35.85 calories. Now I'm not going to get out the calculator yet. I know it's not in the right unit, but I'm just going to make the little notation here so that I can see that I'm going to go from calories to joules. My mass is listed as 20.0 grams. When you look in the problem, you'll see that we have S and not C, but we've already talked about this. You know that C is the same thing as S, little c is the same as S. So we can just put that number in, 0.897 joules per gram degrees Celsius. And reading the problem, the initial temperature is the 75 Celsius, that should say TI. And that's 75 degrees Celsius. The final is what we're solving for, so we can write it as T final minus if we're trying to figure it out. I suggest solving for all of delta T and then substituting the T final minus the T initial after you've solved for delta T. It's easier math. There's less, you have to distribute numbers if you don't do it that way. Now I'm going to go ahead and fix my Q unit by going ahead and using the conversion between calories and joules. So this gives 150.0 joules. Now I'm just going to plug it in the equation. We have 20.0 grams times, notice this is the specific heat of aluminum, 0.897 joules per gram degrees Celsius times your temperature change, which we don't know, but we're going to call the whole thing what we're solving for. And I know that I have 150.0 joules. So I'm dividing both sides so that my delta T is by itself, so by 20.0 grams and 0.97 joules per grams degrees Celsius. Gonna cancel out what's the same. So my delta T is going to turn out to be 8.36 degrees Celsius. Notice that everything in the problem that I worked so far is to 3 sig figs. Sometimes it's helpful in these cases to throw an extra sig fig in. I could have done that. Now I know my delta T, so I'm going to go ahead and solve for my temperature final because remember I knew my T initial was 75 degrees Celsius. So this gives me 8.36 is my delta T. That's equal to T final minus T initial, which is the 75 degrees Celsius. And I do the subtraction. I'm going to get 8.36 plus, remember, because I've added it to both sides. So I'm going to add the 25 to both sides, the 75 to both sides, and I get 83.36 degrees Celsius. Now notice we've got to shorten it to that ones position because 75 is a less precise number. So we're going to draw the line, we're going to shorten it so that it turns out to be 83 degrees Celsius, and that's the answer. That's our final temperature.